Welcome students. This is the second class of sequential circuit. Now in previous class we already discussed about the basic definition of sequential circuit and we also provide the differences between sequential circuit and combinational circuit. Now in that class we already discussed a basic sequential circuit which is called SR latch. Now in this SR latch, this is the characteristics table. Now in this characteristic table, we can observe something. What is that? Now in case of SR latch, see, if both S and R are 0, 0, then the output are in no change condition. Now if I want to change the output, then either S or R should be high. So that is why this is called active high characteristics table or active high SR latch. Now see, in this condition where S and R both are 0, 0 and the present output is 0. Now if I want to make this present output 0 to 1, then I have to high S equal to 1. I have to set S equal to 1 and R equal to 0. Then we can go from 0 to 1. Similarly, if the S and R both are 0, 0, then if the present output is 1 and if I want to change the output to 0, then I have to high R. That means I have to set R equal to 1, then the present output 1 will go to 0. So in both the cases, to change the present output, I have to set either S or R to high value. So that is why this is called active high SR latch. In the next study, we'll discuss about a NAND based implementation of SR latch. So in NAND based implementation, we have two NAND gates. In spite of NOR gates, now we are using two NAND gates. So this is the S input, this is the R input, and this is Q and Q bar. So this is normal output, this is inverted output. Now in case of NAND based approach, if both S and R are 1, 1, then we have no change condition. Means, what is the no change condition? Means if present output, if QT, that means present output is 0, then QT plus 1, that is next state output will be 0. There is no change of the output. If the present output is 1, the next output will also 1. So that is called this state is called no change. Now if S and R, if S equal to 0 and R equal to 1, then this is called set state, that output will be set to 1. Okay, and if that S equal to 1 and R equal to 0, the output will be in reset state. That means the next output will be 0, 0. So the description as we did in the first class, we can do that. Here I will discuss any one of the cases. Suppose if I fix S equal to 0 and R equal to 1. Okay, if I and the present output, I assume that okay, this is 1. So if Q is 1, then present Q bar will be, if Q is 0, that Q bar will be 1. Now we'll analyze this condition. So this Q bar is now connected to this NAND gate. So here it is 0 and it is 1. So 0, 1. If the input of a NAND gate is 0, 1, then what will be the output? The output will be 1. So the output will change to 1. Okay. Now this 1 will come here, the second NAND gate. So both the inputs are 1 now. If both the inputs are 1, the NAND gate output will be 0. Okay. Since this is changed, we will do this again. Now this 0 will come here. So now the NAND gate input is 0 0. So the output will be 1. So output is 1, no problem. Now this 1 will come here and both the inputs are 1. So output will be 0. So if I set S equal to 0 and R equal to 1, the output will be Q will be 1 and Q bar will be 0. Q will be 1 and Q bar will be 0. Okay. Similarly, for every condition, that means for S equal to 1 or equal to 0, we can derive this kind of description. So at the time of exam, if it is asked that describe the operation of SR latch, you have to explain every condition. That means no change condition, reset condition, set condition, as well as the invalid state condition. So you have to write down 4 separate para. In every para, you have to describe what is going on. If I set S equal to R equal to 1, what is going on? If I set S and R are 1 and 0 or 0 and 1. So every step by step we have to explain. Now, as we discussed in the this class, that NOR based implementation is active high implementation, but NAND based implementation is called active low implementation. Why it is called active low? Because normally if I make S and R, if we make S and R equal to high, that means 1, then to change the output from 0 to 1 or 1 to 0, I have to make S low or R low. So I have to change the status of S or R to the low. So that is why this is called active low implementation. If I discuss this in further detail, suppose I take a condition that if S equal to 1, R equal to 1 and my present state is 0, obviously the next state will be 0 because there is no change. Now if I want to change the next state output, that means the present is 0, I want to make it 1. So what we have to do? I have to make S low or R low. So if I make S low, that means if I set S equal to 0, then the present output will be 0 and the next output will be 1. So to make the change in the output, I have to fix S low. That means I have to set S equal to 0. This is true for R also. If I make R equal to 0, then also the 0 becomes 1. Okay. So that is why this NAND based implementation is called active low implementation. Let I clear these pages. So okay, so these are the two things of SR latch. One is active high implementation and another is active low implementation. In these two implementation method, we have two problems. What is that? First one is it is asynchronous design. What do you mean by this asynchronous design? Asynchronous design means if any input, that means set or reset input, if I make any of the input change to 0 or 1, at that time the output will change. Okay. So if I make S equal to 1, then output will change. If I make R equal to 1, then output will change, or 1 or 0, anything. So this kind of circuit is called asynchronous, means we don't have any control over the change of output. Means if due to any situation, if the input changes, then suddenly the output state changes. So we have to have a control circuit which will control the output. If what kind of control circuit? Now, that if input changes, then also the output will not change. It will wait for that control signal to be high or low, then the output will change. Okay. So we have to make this operation synchronous. So that is why we'll introduce another control signal, which is basically called clock. Okay. So this is the problem, that's this asynchronous design, and we have two different different characteristics table. If we go for NOR based implementation, we have an active high characteristics table. If we design for NAND based implementation, then it is an active low characteristics table. So these are the two problems. In the next design problem, we have to solve this. Okay. So what is the requirement of the next design? The circuit will be synchronous operation. Okay, and same logic level table for both NAND and NOR based implementation. Means we will implement NAND or NOR based circuit, no problem. But that characteristics table will be same. Either it will be active high or active low. So these are the two challenges we have to solve in our next design. I'll discuss this next design in my next class. Thank you.